Hello, my name is Simon Dennis, and I'm going to be presenting work on understanding memory for wear using experience sampling technologies. My collaborators were Elizabeth Leliberte, Adelaide McKenzie, Hyungwook Yim, and Ben Stone. This is a pre-recorded presentation for the 2020 meeting of the Society for Mathematical Psychology. In 1984, Ronald Cotton was convicted for 2 counts of rape and 2 counts of burglary. He was sentenced to life plus 50 years. Cotton was exonerated in 1995 after spending over 10 years in prison, when DNA evidence demonstrated it had been Bobby Poole who had committed the crime. This is a famous case in the memory literature because Jennifer Thompson Canino, the victim, identified Cotton in an original photo lineup, but also again in a retrial in 1987. And in this case, Bobby Poole was actually brought into the courtroom along with Cotton, and Thompson Canino chose Cotton again. And so this is a classic case of where the choice that people make is actually being entered into memory and is affecting their subsequent choices. However, there's another important aspect about this case that is often not highlighted, and that's that Cotton misremembered where he'd been at the time of the crime. So he actually identified where he'd been the week before the actual crime, as opposed to where he was at the time of the crime. And so this false alibi led jurors to believe that he was lying. But how reliably can people remember where they've been? What factors affect this memory? What questions might the detective have asked to uncover the false memory? Now, unfortunately, our current laboratory paradigms really don't prepare us to answer these kinds of questions. So the kinds of factors that we're able to manipulate in the laboratory, like fonts or color or things like that, are not really commensurate with the kinds of factors that are important for answering these kinds of questions, like location and so forth. So we need to look to different methods. So what we did is we endeavoured to collect information about people as they went about their everyday lives. So they carried their smartphones with an app that you can see on the left-hand side here, which recorded their movement in the form of accelerometry, where they were in the form of GPS location, and the nature of the sound environment. And from these kinds of information, we're able to build a picture of the nature of the experience that people had at any given time. So on the right-hand side, you can see pictures of and information that we've put together in the unforgettable system based on the raw information. So we can go ahead and augment that raw information with things like what was the weather like, you know, does this audio represent car noise and things like that. So in the first experiment, what we did is we had subjects go out and collect for a month. And we collected accelerometry vectors 10 times a second continuously. So that amounted to about 51 million data points per participant. We collected GPS coordinates every 10 minutes. And so that leads to about 8,640 pairs per subject. And we had audio segments. So these were 3-second segments recorded as Mel frequency Kepstrel coefficients every 10 minutes. There was a 1-week retention interval, and then they received a memory test. Each trial of the memory test involved them selecting from 4 locations. So these were all locations that they had been at some point in time, and what they were given is a particular time, so in this case Thursday morning 8 AM on August 15th, and they had to identify which of the 4 locations they were at. People were accurate about 64% of the time. Now, what we can do, because we have information about each of the different response options, we can look at the distance between the correct answer and those options in different spaces. So we can do that in the actual GPS locations, but we can also do that in terms of the distance between the audio segments that we saw at these different locations and the accelerometry patterns that we saw. And then we can enter those into a conditional logit model to to determine the significance of each of the different dimensions to the choice behaviour. And perhaps unsurprisingly, the GPS location had a much larger impact on the choices that people made than, say, the auditory or the accelerometry. So if a distractor was close to the correct location, it was more likely that it would be chosen. We also looked at time, and here we did this in two different ways. So the most straightforward way is just to look at continuous time and say, how many seconds were there between the correct option and the distractor options. And we did that. But what we found was that categorical time was a better predictor. So by categorical time, I mean when events were similar according to the day and the hour and the week, for instance. So in the day measure here, for instance, what we would do is we would say that 2 times were the same if they appeared on the same day, even if they appeared on different weeks. For the hour measure, we would say that 2 locations were the same if they appeared at the same hour of the day, even if they appeared on different days. And for the week measure, that just indicates did these 2 events appear in the same week or not. And as you can see, these were highly substantial effects, with the day effect being somewhat larger than the other 2. And so this is the error that Cotton made, where he indicated he had the right day, but he had the wrong week. So it does seem like that's a dominant error that people make. So in the second experiment, what we did is we wanted to investigate how do people's emotions affect their the choices that they make. So we had people collect for a 14-day period this time, and we got them to do the same as last time, where they carried the Unforgettable app and collected the passive data. But in addition, we asked them to collect active data, so about their emotions. So this was done using the Thema 3 app, and on 8 times each day, they were queried about 11 distinct emotions, and they had to rate to what extent that they are experiencing those emotions at this particular time. So in this case, people were accurate 67% of the time. So again, we can apply the conditional logic model, and here you can see that all of the emotions that we queried were substantial predictors of which choices would be selected. The positive emotions were slightly more substantial than the negative, but all of the emotions had a very significant effect. What we can also do is look at the type of emotion and how that influences accuracy. So now we're just doing a standard logistic regression rather than conditional regression, and just saying to what extent does that experiencing that emotion at the time of encoding influence your subsequent accuracy. And so one of the interesting things here was the difference between negative and positive emotions. So in the memory literature, which is derived primarily from the laboratory, it's the negative emotions that are typically found to be most substantial. However, in our experiment, we found the opposite. So negative emotions did not differ substantially from 0, whereas the positive emotions did, and they did so in an interesting way. So we divided the positive emotions into higher arousal emotions like excited versus lower arousal emotions like content or relaxed. And you can see that there's a very substantial positive relationship between these lower arousal emotions and the and accuracy. So that's a little bit surprising. And what's perhaps even more surprising is that the high arousal emotions, like excited, showed a negative relationship with arousal. The effect of the low arousal positive emotions may be a consequence of the kinds of places where you tend to experience those emotions. So it might be, for instance, that you feel things like contentment and relaxed at home. At home, that's a high probability place for you to be, and so therefore there might be a bias towards selecting that location, and so that might be why we see that effect. We still don't know why it would be though that there would be a negative relationship with the high arousal positive emotion. So in conclusion, after a 1 to 5 week retention interval, people are able to identify where they were around about 2/3 of the time. That's given 4 options. Distractors that are similar in location or similar in categorical time are more likely to be chosen, and distractors that have similar emotional context are more likely to be chosen as well. Negative emotions at the time of encoding do not predict accuracy, but low arousal positive emotions are associated with better accuracy, while high arousal positive emotions are associated with worse accuracy. Thank you very much.